Have you ever been working with an AI assistant and noticed that most of the code suggestions by the underlying language model itself are actually out of context related to your code base or your architectural patterns or your constraint? Then that is the issue in which we are trying to solve. 42Context is a semantic code search based engine that uses tree-citer to be able to extract code semantics and uses JavaScript to be able to parse the semantics of the code. And with this semantics, we can now store the code as chunks and vector embeddings in a vector database and have our AI query these vector embeddings in the database. So today I'll be walking you through the demo of the 42Context project and also how efficient it is with local development and how it acts as a local context engine. So 42Context uses tree-citer for the language extraction and also uses embedding models to convert the extracted language as embeddings, and these embeddings are stored in a vector database and are provided through the model context protocol. The model context protocol allows us to be able to use tools that can enable the query or the search using semantic search of our code base. This allows the AI assistant or the underlying model to have concrete definitions and concrete data about our code base, which is very important if you're working in a scenario where you have a massive code base or a code base which needs multiple search and have multiple modules. I actually have the code base here for 42Context locally, and here you can see that the current version I have is the latest version, which was deployed. And with the latest version, you have different CLI options. And if I check the different CLI options, you can see that we have the ability to be able to start all the components, the ability to start the indexing, the ability to insert the configuration, the ability to check the status of the vectors that have been saved in the database. So for the local startup, you want to use the start component command, which is going to start all the components needed by the system. So starting the start component command, you can see that all the components have been started, the vector database is up, and you can see that the vector database, which is ChromaDB, is actually up and running. So now we can start by indexing our existing code base to convert that into embeddings and store that in our vector database, and that is going to be able to be used by the LLM through the model context protocol via tools when it wants to think of an implementation or just perform a semantic search. So for a test, I'm going to use the existing module which is present in the code base, and we are going to start the indexing. So what this is going to do is that this is going to extract the semantics of the code structure in your existing code base using tree-citer, and rather than passing it as a plain text. And now these extracted code chunks are going to now be embedded using our embedding model. The embedding model now is going to convert these code chunks as vector representations, which are going to be represented in our database. So right now I'll start the indexing, and you can see that the parsing has started, and the optimizer which we implemented for the parsing is actually working, and you can see it's actually going through each folder and indexing the code base and creating the embeddings for each code sections or code pieces which we have using tree-citer. So I'll just leave it for it to complete. So right now you can see that the generation process of the embeddings is complete. And you can see we successfully indexed the entire folder, and you can see in the ChromaDB UI that we implemented, you can see actually the different modules and the different files which have been indexed and how they are present in the database. And these files now can be queried directly via your LLM to provide a clear context to relationships and also how your architecture looks like to the LLM. In such a way, it's going to be able to provide a great understanding and a concrete implementation when you're prompting. So right now I'm using KiloCode for testing, and KiloCode is a dedicated client which can be used, but you can use any dedicated client which supports the model context protocol. So I will just set up the MCP server directly on KiloCode, and you can see I already have the MCP server set up in KiloCode. You can see the JSON configuration here, and literally the JSON configuration just uses the standard input output to pass the response. So you can also use the same JSON configuration, or you can explore the code base itself to understand how to do that. So I have my keys configured here for advanced search, but this is not the main functionality. And here you can see that we have related tools implemented, which is the code search tool, context analysis tool, find related code tool, and the find implementation tool. So these tools are going to be able to be used directly against our vector database, and we are going to be able to perform semantic query directly against our vector database. And this context is going to be passed to the LLM as additional context. So why is this important? This is important because LLMs out of the box does not understand the architecture, design, and also how detailedly a project structure looks like, because they just have what is supposed to be made in their training data. But with this now, we have the ability to pass the architectural decisions and also the different flows in our application to allow the LLM to be able to query our application and also provide intelligent suggestions, right? So that is the main point. So right now, I will just test the MCP connection. I will just say use the code search tool. To use the code search tool to understand how the embedding process is implemented in this code base. So I will just say do not read any file, right? So I'll just send this prompt, and actually you're going to see the LLM now making an API call to the MCP server, and from the MCP server it's going to now get a response. You can see the call here, and from this call you can see it's doing a normal semantic search and it's searching for embedding process initialization vector generation, and you can see it's doing the normal response, and from the response, this response is going to be added as additional context to the LLM. And with this additional context, it can get an eagle eye view of exactly how the implementation of the vector generation and the embedding process in our code base looks like. So you can see this is added as additional context, and it goes on doing more tool calls to understand properly how this is implemented, and it gives a response. So typically this is a normal response, and it's able to feed through this response to actually understand how this functionality is implemented in our code base. And this is optimal than in a normal prompt generation process or sending a prompt process, because now you can have a general understanding of the code base itself and also be able to make edits using our existing patterns and existing structure. So this is the main importance of this type of architecture and the main importance of the 42Context local context engine. So you can see it passes more data here and feeds this data to the LLM, right? And now it gives us a response based on the data and the response which it received directly. So here you can see it has the embedding service and also embedding optimizer, which it did not actually do using the right tool provided by KiloCode, and also do a read tool to read the file directly, or do a write tool to write into the file. It actually just uses this MCP server directly and is able to do this semantic search against the database, right? So this is the power of the 42Context tool. I hope you can test it out, play around with it, and see how optimal it is for your own workflow, right? Yeah, so I'll just go back to the repository, and you can see in the repository here we have the readme. From the readme, we have a lot of CLI options where you can also play around with them. We have a lot of CLI options here to do a normal search, right? So from this normal search, you can actually be able to explore the code base. So I hope you find the video helpful. You can leave a comment, or if you have any questions, just reach out. Yes, then bye for now.